Here we're going to look at the absorptive and post-absorptive states. These are what happen when you eat and between meals. This ties in a lot with chapter 17. When we learned about hormones, you learned about insulin and glucagon and how they regulate your blood nutrients. This is going to be about insulin and glucagon and blood nutrients. So we'll start off with the absorptive state. Absorptive state is what happens when you eat. When you eat, your intestine puts nutrients into your blood. So we have nutrients going from the blood, and remember you have three basic types of nutrients. We're going to have glucose, amino acids, and lipids. So you digest carbohydrates into glucose, you digest proteins into amino acids, and you digest your lipids into, it's going to be mainly triglycerides. And with the lipids, they go through the lymph first. Remember, they're picked up by lacteals, but then lymph goes into the blood. So they do end up in your blood. So during this time, you have a rise in blood nutrient levels. Now remember, you always want to maintain homeostasis. So you don't want your blood nutrient levels to be too high. So your pancreas, you can see it tucked back here behind the stomach. It monitors your blood glucose. It's not monitoring so much the amino acids and triglycerides, but it just assumes that if glucose is high, the other nutrients are high also. But glucose is the one that your pancreas responds to. So in this situation, when blood glucose is high, the pancreas secretes insulin. So now we have insulin from the pancreas going into the blood also. The job of insulin is to reduce the blood level of nutrients. So you're going to move nutrients out of the blood and into other tissues. So we have glucose is going to go in the liver and be stored as glycogen. And if you remember those terms from chapter 17, this is going to be glycogenesis, formation of glycogen. You're also going to do that in your muscles. So you will get glycogen in your skeletal muscles, also through glycogenesis. The amino acids will go into your muscles where you will do protein anabolism. So you will build the amino acids into protein, and you will also do that in your cells. So this last picture here just represents cells in general in the body. The cells in general will also take glucose in response to insulin, and they are going to use the glucose to make ATP. Then we have the triglycerides are going to go here to your adipose. So that's a picture of some adipocytes. And you're going to do lipogenesis. And you're going to store the triglycerides as adipose. So you're going to add to your body fat. So now that the nutrients have moved out of the blood, the result is reduced blood nutrients. And you have an increase in storage, so you have your glucose and your lipids are stored. You also have an increase in cells using glucose to make ATP. And you have an increase in the amount of protein in your body because you did protein anabolism. So this is what happens when you eat, this absorptive state. Now let's look at the post-absorptive state. This is between meals. Your small intestine is no longer sending nutrients to the blood. So there's nothing here. That's all done. So that means that your blood nutrient levels start to fall. So remember, homeostasis. You want to maintain those nutrient levels. So now your pancreas is again going to respond. The pancreas will respond to the drop in glucose. And it secretes glucagon. So now you're going to put glucagon in your blood. And the job of glucagon is to raise blood nutrients by moving the nutrients out of tissues and into the blood. So your liver has the glucose. We're going to return that to the blood. So you're going to do glycogenolysis. So remember, lysis means break. So this is where you will break the glycogen and return the resulting glucose to the blood. So glycogen is just a bunch of glucose stored together. So when you break the glycogen, then you're back to having a bunch of individual glucose. And here with the adipose, we're going to return triglyceride to the blood. And that is lipolysis. So this is where lysis break, you're going to break your adipose and return the resulting triglyceride to the blood. So notice that glucagon reverses only 2 of the things that insulin did. There's other things that glucagon does not do. Glucagon, let's make a heading here. It does not, so we'll list the things glucagon does not do and why it doesn't do them. It does not return glucose from the muscles. That's because the muscles will use that glucose. It also does not return glucose from your cells. Because remember, the cells used that glucose to make ATP. That glucose is now converted to carbon dioxide and water. They can't return it. So think back to chapter 3 when we learned about cellular respiration. When you break down glucose, it ends up combining with the oxygen that you inhale to become carbon dioxide and water. We also do not return any amino acids to the blood. It's because these amino acids are now part of the proteins of your body. And your body doesn't like to break down its proteins. You don't want to sacrifice these proteins you've built. Okay, so there's everything glucagon does and doesn't do. So between these two states, all the time, you're either eating and you're an absorptive, or you're between meals and you're post-absorptive. So your pancreas, with its insulin and glucagon, keeps you in balance of your blood nutrients all the time.